Screen printing is a printing technique that uses a woven mesh to support an ink-blocking stencil to receive a desired image. The attached stencil forms open areas of mesh that transfer ink or other printable materials which can be pressed through the mesh as a sharp-edged image onto a substrate. A fill blade or squeegee is moved across the screen stencil, forcing or pumping ink through the mesh openings to wet the substrate during the squeegee stroke. Basically, it is the process of using a mesh-based stencil to apply ink onto a substrate, whether it be t-shirts, posters, stickers, vinyl, wood, or other material. Screen printing is also a stencil method of printmaking in which a design is imposed on a screen of polyester or other fine mesh, with blank areas coated with an impermeable substance. Ink is forced in the mesh openings by the fill blade or squeegee and onto the printing surface during the squeegee stroke. As the screen rebounds away from the substrate, the ink remains on the substrate. It is also known as silkscreen, serigraphy, and serigraph printing. One color is printed at a time, so several screens can be used to produce a multicolored image or design. Etymology: there are various terms used for what is essentially the same technique. Traditionally, the process was called screen printing or silkscreen printing because silk was used in the process prior to the invention of polyester mesh. Currently, synthetic threads are commonly used in the screen printing process. The most popular mesh in general use is made of polyester. There are special use mesh materials of nylon and stainless steel available to the screen printer. There are also different types of mesh size which will determine the outcome and look of the finished design on the material. Encyclopedia references: encyclopedias and trade publications also use an array of spellings for this process, with two most often encountered English spellings, the more popular being the two-word title screen printing without hyphenation, and less commonly screen printing spelled as a single undivided word. History: screen printing is a form of stenciling that first appeared in a recognizable form in China during the Song dynasty. It was then adapted by other Asian countries like Japan, and was furthered by creating newer methods. Screen printing was largely introduced to Western Europe from Asia sometime in the late 18th century, but did not gain large acceptance or use in Europe until silk mesh was more available for trade from the East and a profitable outlet for the medium discovered. Early in the 1910s, several printers experimenting with photoreactive chemicals used the well-known actinic light-to-Euro-activated cross-linking or hardening traits of potassium, sodium or ammonium chromate and dichromate chemicals with glues and gelatin compounds. Roy Beck, Charles Peter and Edward Owen studied and experimented with chromic acid salt-sensitized emulsions for photoreactive stencils. This trio of developers would prove to revolutionize the commercial screen printing industry by introducing photo-imaged stencils to the industry, though the acceptance of this method would take many years. Commercial screen printing now uses sensitizers far safer and less toxic than bichromates. Currently there are large selections of pre-sensitized and user-mixed sensitized emulsion chemicals for creating photoreactive stencils. A group of artists who later formed the National Serigraphic Society coined the word serigraphy in the 1930s to differentiate the artistic application of screen printing from the industrial use of the process. Serigraphy is a compound word formed from Latin sericum, and Greek graphene. The Printers' National Environmental Assistance Center says screen printing is arguably the most versatile of all printing processes. Since rudimentary screen printing materials are so affordable and readily available, it has been used frequently in underground settings and subcultures, and the non-professional look of such DIY culture screen prints have become a significant cultural aesthetic seen on movie posters, record album covers, flyers, shirts, commercial fonts in advertising, in artwork and elsewhere. History 1960s to present. The father of the serigraphic process belongs to Guy McCoy. In 1933 McCoy left the Art Student League to begin work within the Work Project Administration under Dr. Herbert H. Spendon and directed by Ben Knotts. McCoy is credited with murals that were created for Central American Arts and Girls Industrial High School. The following year, New York Mayor LaGuardia instituted a large poster project, in which Guy became deeply involved. During the Great Depression, Many artists were searching for a means to reproduce their original works faithfully, to offer additional revenue options from painting singular originals. McCoy had been developing ideas for a printing process utilizing a silkscreen and experimenting with various components and mediums to produce the desired results. McCoy held the first one-man show of the newly named serigraphs at the Contemporary Art Gallery in 1938, featuring his works, Woman Holding Cat, and Still Life. In 1940 Guy graduated from Columbia University with his Bachelor of Arts in Teaching and moved to Vermont where he took up work with the Polygraphic Lithographic Company as a color separator and dot etcher on the zinc lithographic plates. During this time McCoy continued to refine the serigraphic process. In 1941 he got involved with the Workshop, which was the predecessor to the National Serigraph Society, where McCoy was directly involved up to 1947. In 1945 McCoy left Vermont for Los Angeles, California. Other artists and serigraphers followed McCoy to the West Coast. In 1948 McCoy formed the Western Serigraph Society and became its first president. Credit is generally given to the artist Andy Warhol for popularizing screen printing as an artistic technique, identified as serigraphy, in the United States. Warhol is particularly identified with his 1962 depiction of actress Marilyn Monroe screen-printed in garish colors. Sister Mary Corritter Kent gained international fame for her vibrant serigraphs during the 1960s and 1970s. Her works were rainbow-colored, contained words that were both political and fostered peace and love and caring. American entrepreneur, artist and inventor Michael Vacilon started to use, develop, and sell a rotary multicolor garment screen printing machine in 1960. Vacilon later filed for patent on his invention in 1967, granted number 3,427,964 on February 18, 1969. The original rotary machine was manufactured to print logos and team information on bowling garments but soon directed to the new fad of printing on T-shirts. The Vacilon patent was licensed by multiple manufacturers. The resulting production and boom in printed T-shirts made the rotary garment screen printing machine the most popular device for screen printing in the industry. Screen printing on garments currently accounts for over half of the screen printing activity in the United States. In June 1986, Mark Tartaglia Jr. and Michael Tartaglia created a silk screening device which is defined in its U.S. patent document as, multicolored designs are applied on a plurality of textile fabric or sheet materials with a silk screen printer having 7 platoons arranged in 2 horizontal rows below a longitudinal heater which is movable across either row. This invention received the patent number 4,671,174 on June 9, 1987, however the patent no longer exists. Graphic screen printing is widely used today to create many mass or large batch-produced graphics, such as posters or display stands. Full-color prints can be created by printing in CMYK. Screen printing lends itself well to printing on canvas. Andy Warhol, Rob Ryan, Blix Bolex, Arthur Okamura, Robert Rauschenberg, Roy Lichtenstein, Harry Gottlieb, and many other artists have used screen printing as an expression of creativity and artistic vision. Printing technique. A screen is made of a piece of mesh stretched over a frame. A stencil is formed by blocking off parts of the screen in the negative image of the design to be printed. That is, the open spaces are where the ink will appear on the substrate. Before printing occurs, the frame and screen must undergo the pre-press process, in which an emulsion is scooped across the mesh and the exposure unit burns away the unnecessary emulsion, leaving behind a clean area in the mesh with the identical shape as the desired image. The surface ensures that the substrate will be printed against is coated with a wide palette tape. This serves to protect the palette from any unwanted ink leaking through the substrate and potentially staining the palette or transferring unwanted ink onto the next substrate. Next, the screen and frame are lined with a tape. The type of tape used for this purpose often depends upon the ink that is to be printed onto the substrate. These aggressive tapes are generally used for UV and water-based inks due to the ink's lower viscosities. The last process in the pre-press is blocking out any unwanted pinholes in the emulsion. If these holes are left in the emulsion, the ink will continue through and leave unwanted marks. To block out these holes, materials such as tapes, specialty emulsions and block-out pens may be used effectively. The screen is placed atop a substrate. Ink is placed on top of the screen, and a flood bar is used to push the ink through the holes in the mesh. The operator begins with a fill bar at the rear of the screen and behind a reservoir of ink. The operator lifts the screen to prevent contact with the substrate and then using a slight amount of downward force pulls the fill bar to the front of the screen. This effectively fills the mesh openings with ink and moves the ink reservoir to the front of the screen. The operator then uses a squeegee to move the mesh down to the substrate and pushes the squeegee to the rear of the screen. The ink that is in the mesh opening is pumped or squeezed by capillary action to the substrate in a controlled and prescribed amount. That is, the wet ink deposit is proportional to the thickness of the mesh and/or stencil. As the squeegee moves toward the rear of the screen, the tension of the mesh pulls the mesh up away from the substrate, leaving the ink upon the substrate surface. There are three common types of screen printing presses: the flatbed, cylinder, and the most widely used type, the rotary. Textile items printed with multicolored designs often use a wet-on-wet technique, or colors dried while on the press, while graphic items are allowed to dry between colors that are then printed with another screen and often in a different color after the product is realigned on the press. Most screens are ready for recoating at this stage, but sometimes screens will have to undergo a further step in the reclaiming process called dehazing. This additional step removes haze or ghost images left behind in the screen once the emulsion has been removed. Ghost images tend to faintly outline the open areas of previous stencils, hence the name. They are the result of ink residue trapped in the mesh, often in the knuckles of the mesh. While the public thinks of garments in conjunction with screen printing, the technique is used on tens of thousands of items, including decals, clock and watch faces, balloons, and many other products. The technique has even been adapted for more advanced uses, such as laying down conductors and resistors in multi-layer circuits using thin ceramic layers as the substrate. Stenciling techniques. A method of stenciling that has increased in popularity over the past years is the photo-emulsion technique. The original image is created on a transparent overlay, and the image may be drawn or painted directly on the overlay, photocopied, or printed with a computer printer, but making so that the areas to be inked are not transparent. A black and white positive may also be used. However, unlike traditional plate making, these screens are normally exposed by using film positives. A screen must then be selected. There are several different mesh counts that can be used depending on the detail of the design being printed. Once a screen is selected, the screen must be coated with emulsion and put to dry in a dark room. Once dry, it is then possible to expose the print. The overlay is placed over the screen, and then exposed with a light source containing ultraviolet light in the 350 to 420 nanometer spectrum. The screen is washed off thoroughly. The areas of emulsion that were not exposed to light dissolve and wash away, leaving a negative stencil of the image on the mesh. Another advantage of screen printing is that large quantities can be produced rapidly with new automatic presses, up to 1,800 shirts in 1 hour. The current speed loading record is 1805 shirts printed in 1 hour, documented on February 18, 2005. Maddie Sikorsky of the New Buffalo Shirt Factory in Clarence, New York set this record at the Imageware Expo in Orlando, Florida, USA, using a 12-color M&R formula press and an M&R Passport automatic textile unloader. The world speed record represents a speed that is over 4 times the typical average speed for manual loading of shirts for automated screen printing. Screen printing materials, caviar beads. A caviar bead is a glue that is printed in the shape of the design, to which small plastic beads are then applied. Works well with solid block areas, creating an interesting tactile surface. Cracking ink. Cracking ink effect is when the ink produces an intentional cracked surface after drying. Discharge inks. Discharge ink is used to print lighter colors onto dark background fabrics. They work by removing the dye of the garment. This means they leave a much softer texture. The cons with this process is that they are less graphic in nature than plasticel inks, and exact colors are difficult to control. One of the pros of using this process is they are especially good for distressed prints and underbasing on dark garments that are to be printed with additional layers of plasticel. It adds variety to the design or gives it that natural soft feel. Expanding ink, or puff, is an additive to plasticel inks which raises the print off the garment, creating a 3D feel and look to the design. Mostly used when printing on apparel. Flocking. Flocking consists of a glue printed onto the fabric and then flocked material is applied for a velvet touch. Foil. Foil is much like flock, but instead of a velvet touching look it has a reflective mirror look to it. Although foil is finished with a heat press process, it needs the screen printing process in order to add the adhesive glue onto the material for the desired logo or design. 4-color process or the CMYK color model. 4-color process is when the artwork is created and then separated into 4 colors which combine to create the full spectrum of colors needed for photographic prints. This means a large number of colors can be simulated using only 4 screens, reducing costs, time, and setup. The inks are required to blend and are more translucent, meaning a compromise with vibrancy of color. Glitter shimmer. Glitter or shimmer ink is when metallic flakes become an additive in the ink base to create this sparkle effect. Usually available in gold or silver but can be mixed to make most colors. Gloss. Gloss ink is when a clear base laid over previously printed inks to create a shiny finish. Metallic. Metallic ink is similar to glitter, but smaller particles are suspended in the ink. A glue is printed onto the fabric, then nanoscale fibers applied on it. This is often purchased already made. Mirrored silver. Mirrored silver is a highly reflective, solvent-based ink. Nylabond. Nylabond is a special ink additive for printing onto technical or waterproof fabrics. Plasticel. Plasticel is the most common ink used in commercial garment decoration. Good color opacity onto dark garments and clear graphic detail with, as the name suggests, a more plasticized texture. This print can be made softer with special additives or heavier by adding extra layers of ink. Plasticel inks require heat for many inks, to cure the print. PVC and phthalate-free. PVC and phthalate-free is relatively new breed of ink and printing with the benefits of plasticel but without the 2 main toxic components. It also has a soft texture. Suede ink. Suede ink is a milky colored additive that is added to plasticel. With suede additive you can make any color of plasticel have a suede feel. It is actually a puff blowing agent that does not bubble as much as regular puff ink. The directions vary from manufacturer to manufacturer, but generally up to 50% suede can be added to normal plasticel. Water-based inks. These penetrate the fabric more than the plasticel inks and create a much softer feel. Ideal for printing darker inks onto lighter colored garments. Also useful for larger area prints where texture is important. Some inks require heat or an added catalyst to make the print permanent. Versatility. Screen printing is more versatile than traditional printing techniques. The surface does not have to be printed under pressure, unlike etching or lithography, and it does not have to be planar. Different inks can be used to work with a variety of materials, such as textiles, ceramics, wood, paper, glass, metal, and plastic. As a result, screen printing is used in many different industries, including balloons, clothing, decals, medical devices, printed electronics, including circuit board printing, product labels, signs and displays, snowboard graphics, textile fabric, thick film technology, semiconducting material, in-screen printing on wafer-based solar photovoltaic cells. The mesh and buses of silver are printed on the front. Furthermore, the buses of silver are printed on the back. Subsequently, aluminum paste is dispensed over the whole surface of the back for passivation and surface reflection. One of the parameters that can vary and can be controlled in screen printing is the thickness of the print. This makes it useful for some of the techniques of printing solar cells, electronics etc. One of the most critical processes to maintain high yield. Solar wafers are becoming thinner and larger, so careful printing is required to maintain a lower breakage rate. On the other hand, high throughput at the printing stage improves the throughput of the whole cell production line. Screen printing press. to print multiple copies of the screen design on garments in an efficient manner. Amateur and professional printers usually use a screen printing press. Many companies offer simple to sophisticated printing presses. Most of these presses are manual. A few that are industrial-grade automatic printers require minimal manual labor and increase production significantly. Rotary screen printing, a development of screen printing with flat screens from 1963, was to wrap the screen around to form a tube, with the ink supply and squeegee inside the tube. The resulting roller rotates at the same speed as the web in a roll-to-roll machine. The benefits are high output rates and long rolls of product. This is the only way to make high-build fully patterned printing. Coating as a continuous process, and has been widely used for manufacturing textured wallpapers. A large number of such machines have been supplied by Stork BV. Example images. See also: dye, glass, Gocco, inkjet, multi-layer, metal, plastic, printed electronics, printed t-shirt, roll-to-roll printing, serialithograph, sphecia screen printing machines, textile printing. Notes. Further reading: Jacob I. Bigelizan, Screen Printing, A Contemporary Guide. New York, 1972. Andy McDougall, Screen Printing Today, The Basics. Street Media, Cincinnati, 2008. Guido Lengwala, A History of Screen Printing. Street Media, Cincinnati, 2013. Stephen Abbott, http://www.stephenabbott.co.uk. How % 20 to % 20 B % 20 A % 20 Great % 20 Screen % 20 Printer PDF. External links: American Screen Printing Association, Incorporated. The Federation of European Screen Printers Associations, WO Euro. Unregistered trademark SHU in screen printing.